Inside an industrial ammonia refrigeration system, the physical environment is brutal. At -28 degrees Fahrenheit, steel pipes hold back highly pressurized, toxic refrigerant. Yet, across the industry, the defense against this extreme physical force is increasingly reduced to a binder of paperwork sitting on a desk. Before we dig into this, please note, this video is for educational purposes only and is not legal or engineering advice. Always follow OSHA 29 CFR 1910.119, EPA RMP rules where applicable, and your specific facilities requirements. Industrial refrigeration is experiencing a dangerous drift. Facilities are pouring immense resources into achieving paperwork compliance, checking every box on an audit form, while simultaneously losing the hands-on mechanical expertise required to actually stop a catastrophic failure. When an industrial site stores over 10,000 pounds of anhydrous ammonia, the stakes leave no room for clerical errors. Ammonia is incredibly toxic. If a major line ruptures, the concentration quickly exceeds IDLH limits, levels immediately dangerous to life or health. The resulting toxic clouds or confined space explosions yield devastating consequences for both plant personnel and the surrounding community. This wheel breaks down the 14 elements of OSHA's Process Safety Management Standard, or PSM. It is designed to prevent those disasters by mandating strict rules for process hazard analysis, operating procedures, training, and mechanical integrity. But a PSM program only works when it operates as a living, breathing defense system. Treating it as a static document leaves a facility blind to its actual physical risks. Take the Process Hazard Analysis, or PHA. This is supposed to be a rigorous, exhaustive review of what could go wrong. Instead, it has largely been commoditized. Facilities often hire third-party facilitators who rely heavily on software to simply read questions off a spreadsheet. The danger here is subtle but severe. You might have someone leading your hazard review who has never physically turned a frost-covered valve, drained oil from a receiver, or manually managed a hot gas defrost cycle. To fix this, plant managers need to evaluate vendors using a PHA facilitator scorecard. This means grading potential hires on their actual ammonia field experience and human factors training, rather than just taking the lowest bid. Ask them specific operational questions. Ask how they evaluate human factors when a high-level alarm is blaring in the engine room at 2 a.m. and the operator has to make a split-second decision. The reputation of the consulting firm doesn't matter if the specific individual assigned to your facility doesn't understand the physics of your system. You have to vet the person in the chair. That same blind spot exists internally with the people who manage the paperwork, the PSM coordinators. This organizational chart shows a dangerous blur. Tracking compliance documents is administrative, but technical safety validation requires engineering knowledge. This liability peaks during the management of change process. Forcing a non-engineer to co-sign a technical MOC creates an administrative bottleneck and a massive safety gap. They can verify that the paperwork is filed correctly, but they cannot physically evaluate whether modifying a section line will inadvertently starve a compressor of oil. While these administrative gaps create long-term liabilities, the most immediate physical threat right now comes from how the industry is treating the people turning the wrenches. Facilities have to draw explicit lines around technical authority gates, know exactly who has the engineering background to approve a physical change, and keep the administrative roles focused on the system structure. Out in the engine room and on the plant floor, industrial refrigeration is facing historic labor turnover. The definition of a qualified operator is shifting. The traditional timeline to become a competent operator used to require years of closely supervised apprenticeship. Today, out of sheer necessity, that timeline is frequently compressed into just weeks. This creates a hidden risk of partial experience. An operator transferring from a sister plant is still a liability on day one because valve lineups, piping layouts, and emergency alarm philosophies change entirely from building to building. This grid is what we call an operator competency matrix. Instead of assuming capability based on tenure, it tracks task-specific proficiency and the exact dates those skills were physically verified. Operator capability can no longer be assumed from a resume. It must be explicitly defined, drilled on the floor, and constantly reassessed. To cope with this severe shortage of in-house operators, entire facilities are now outsourcing their daily rounds and mechanical integrity checks to third-party contractors. But bringing in a third party does not automatically mean you are bringing in a qualified party, and you can never outsource your facility's liability. Pay attention to the red flags. If a contractor shows weak lockout-tagout discipline, or if they can't accurately explain the logic behind your emergency shutdown system, they're introducing risk into your facility. This timeline highlights a critical upcoming date. Tightening EPA regulations and the January 2026 deadline for the IIAR 9 Minimum System Safety Evaluation are specifically targeting these operational blind spots. Audits are shifting to focus heavily on actual mechanical integrity. The impending rules leave absolutely no room for hollow paperwork. True process safety management relies exclusively on the verified, hands-on competency of human beings. If you want to learn more about workplace safety and OSHA rules, subscribe to HSEstudy.